All right, let me give you another little hint. Here we go. With all the given information, here's where I started. After we finished up the last video, this is where we were to find out the actual radius. That was the initial, if you will, goal. So, what I realized is since this triangle is equilateral, I'm going to use this formula. The area of an equilateral triangle is s squared over 4 root 3. So I'm going to try to find the side length of this particular triangle because maybe that's going to help me, maybe it's not, but that's about all I can go off of right now. So if I do that, here's what I've done. I've taken the area of the triangle, which was given to me to be 36 root 3 units squared, and I put that in for the area. So then I do some algebra to solve for the side length, because that's my only missing piece. And how I do that is I actually take this formula and I multiply both sides by 4. So what I do to one side, I must do to the other side. So when I multiply this by 4, it actually does this. It cancels the actual denominator with that factor right there, 4. And then I take 4 times 36, which gives me 144 root 3. Remember, you don't take the 4 times the thing inside. It just is 4 times the thing outside. So 144, phenomenal. So 144 root 3 equals this s squared. So now, what I'm going to do with this is I'm going to take this whole thing, algebra-wise, and divide by root 3. Why would I divide by root 3? Because down here I'm multiplying s squared, multiply root 3. So the inverse operation of multiplication and division. So I divide, which means I divide this over here by root 3. So the root 3's cancel, the root 3's cancel. I'm left with s squared. Oh, s squared equals 144. Square root both sides. It is actually plus or minus the 12, but again, the negative 12 doesn't make sense because you can't have a negative side length of a triangle. So it's extraneous solution. It's gone. So this is the side length from G to P. So that is 12. So we got that piece. Now hold on a second. What we remember about point I is that it is the midpoint of the segment. So that means this piece here from G to I and I to P has to be 6. Hoo-hoo. Now we're getting somewhere. Remember, my goal still is to find this length right here. That length of that radius. That is the goal, because when I plug that in there, I'll be able to find my answer. Well, there's your hint. What I'd recommend doing now is maybe drawing and making a triangle somewhere using this particular segment, radius, whatever. Because remember this, a radius drawn to a point of contact is, fill in the blank. Good job. It is perpendicular. So a radius drawn to a point of contact is perpendicular. So, if I take this, and let's say, for example, I draw a line that goes right over here, like such, I've just created a right triangle where it is right triangle OPI. So there is your next hint. I'm going to pause this video. I'm going to stop it actually, and you continue from there. Remember, the goal is to find the radius. Good luck. All right, last step. Here we go. You'll see if you got it or not. I believe that you did. I can just see it in your eyes. Wait, blink. I think you got it right. Good job. So here we go. We're at this stage right here. We drew this. The only thing I don't have in this picture, sorry, is this is a right angle. We talked about that. Okay. So my goal now is to find this still, not my goal now, it's the initial goal, to find that radius length because that'll give me my overall goal of finding the area of the circle. That is the overall happy goal. So if I look at this triangle OIP, I pulled it out over here. What I know is this. I know that that's a 90-degree angle. I don't know the measure of this angle, and I don't know the measure of this angle. But wait a minute. Maybe I do know the measure of that angle. Maybe I do know the measure of this angle right here. Because this is an equilateral triangle, GAP. So in an equilateral triangle, that means it's equiangular. So this whole angle right here is actually 60. Now you can go through, and you're kind of guessing right now, but you could go through and draw this radius and then actually prove that this triangle here, I'll make this X, OXP, you could prove that that triangle is congruent to this triangle OIP, which then would mean that these two angles right here are congruent. So really what happens is this thing that I drew out to that vertex bisects the bigger angle. That being said, this is 30. Why is that important? Because if that's 30 and this is 90, well by golly, that means this has to be 60. So what I'm looking at is now a 30, 60, 90 triangle. And I know you know this, but across my 30-degree angle is what x is. Across my 90-degree angle is what 2x is. Across my 60-degree angle is what x root 3 is. So here is my equation, of which all I have to do is solve for x, because when I solve for x, I can plug that right in there, and that, remember, OI, is my radius length, which will help me find the area of the circle. This is a great question. I'm glad I came up with it. So over here, I have an equation, x root 3 equals 6. What we've done in class, you've seen this, and or through different videos. We divide both sides by root 3 to cancel that. So I'm left with this. You never want to leave a radical in the denominator, so you got to rationalize the denominator like we did in class. Root 3 over root 3, which means on top I get 6 root 3. This gives you 9. So when I multiply that, or not multiply, I actually simplify it now. I can simplify the things outside of the radicals. So that gives me, whoa, that's not right, I made a mistake. I'll back up. Whew, did you catch that? Did you catch it? Sorry, the lights just blinked and the power went out, so it was weird. Threw me off my game. I'm back though, I'm back, don't worry. So root 3 times root 3 actually gives you the square root of 9, which would give you a 3. Now we're on track. Glad you caught that. So I can reduce the 6 and that 3, which means now I get 2 root 3. Whoa, that is now my x value. Wait, that's what I wanted. That's my x value. That's this piece. That's from here, O to I, which is my radius. Nice. So I finally have my radius length. Well, let's plug it in then. I have the area of the circle is pi times the radius, 2 root 3 squared. Now I'm going to caution you, just like in the other example, make sure you're careful when you do 2 root 3 squared. Because remember, that's the same thing as 2 root 3 times 2 root 3. If you're going to use your calculator, be very careful. Make sure you put parentheses around it. So that should give you pi area. That will give you 12 right there when you take 2 root 3 and square it. Now I would clean this up. I wouldn't leave it that way. You would do area equals 12 pi units squared. So there you go. Did you get it? Haha. Well, there you go. Go back and look at it again. It's a great question. But here's the thing I want to make sure you're clear on. The directions did not say, I'll pull this back so you can see. The directions did not say anything about, finding to the nearest tenth or anything like that. It just says find the area of the circle. Remember, if it doesn't specify to the nearest tenth, then you don't do it to the nearest tenth. Don't multiply stuff and get a decimal answer. You keep it in simplified radical form, which is what we actually got here. Well, it's not simplified, it's not radical form, but it's simplified pi form, whatever. So if it said, though, if the direction said to the nearest tenth, well, then you would actually take 12 times 3.14 and get your decimal, and then that's your answer. But the directions here did not specify, so you don't do it. So there you go. Hope you got it right. Look forward to seeing you in class. Later.